All right, so one of the things that we want to do when we're, say, looking at our own network, or we've been, say, paid to go look after someone else's network or go break into someone else's network, first thing you want to do is, after you do all your recon, is once you get a foothold on that network, see what else you have access to, right? So a lot of people will do this via just drive-by scanning, okay? Have you guys ever done this with your laptop or anything, or your cell phone, put like a Wi-Fi analyzer on it and just go driving around your neighborhood to see how many of your neighbors' Wi-Fi's pop up on your phone? And it'll show you which ones are locked and which ones are unlocked. If you've got one that's locked, you know, you can have a little tougher time getting in, but you'll probably get in, no problem, eventually. But ones that are unlocked, you can just start using it right then and there. Okay, so this is why it's really important to lock down your own home's internet, okay, like your Wi-Fi. You need to put in a very long and strong password, because let's say your neighbor is not a very, nice person, okay? Say he's got a very morally casual attitude, and he decides he likes to look at child porn, okay? Well, he don't want to do it on his network. What's he going to do? If yours is unlocked, he's going to use yours. Or if you got a weak password, he's going to use yours. Guess who gets in trouble for that? Yeah, you guys are the first ones that are going to be getting in trouble. I mean, literally, if they do something bad on your network because you didn't have it locked down, you're the one that's going to be talking to the FBI first. And then, maybe after a couple of weeks, they'll figure out that it was your neighbor. But you're going to be in deep kimchi, as we used to say, while you're getting all that sorted out. So it's a really good idea to lock down your home network. But once someone gets on here, there's a tool out there called NMAP. And there's another tool that's called Mass Scan. You can look at that one if you want. It does the exact same thing, except Mass Scan does it a whole lot faster. You can actually compile a Linux kernel with the right driver, a high-performance Ethernet driver, that's been written with NMAP in mind, or not NMAP, but Mass Scan in mind. And you could literally scan the entire internet in just a matter of days, probably. Which, with that number of IPs, NMAP would take probably a number of years to do it. You'd be blocked before it ever got finished. All right, so we're going to look at a couple of things here with NMAP. Let's make sure I got this open, and I'm going to go ahead and open up a couple of other virtual machines just so we can see what's happening on this machine before we turn it loose on the entire school. So let's open up a Windows machine and another like Ubuntu machine. And like I say, I'm using Parallels on this just because it's easier with Mac to bounce between things. So the problem is you got to pay for it, and it's not much, but it's a paid software. All right. All right, so we got Ubuntu up, we got Windows up, and we got Kali up. All right, so right off the bat, let me bring my notes up again so I can stay on track, because I like to ramble. Oh, that was it. All right, we're going to start out with just some basics. Like what NMAP is going to do is you can just do a ping sweep. Remember how we did ping to see if a machine was up? Okay, we can do a ping sweep of the entire network. All right, and let's see here. It's probably already in here. Bring this up. I had this on my bigger monitor, and everything is now not to the right size. There we go. All right, so we're just going to do a SP. There it was. All right, so we got to change the address here. Can y'all see that? That probably needs to be bigger, doesn't it? Zoom in. We have to do it manually, I guess. All right, can y'all see that a little bit better now? Still looks small. All right, so what we're doing is we're going to use obviously sudo, because this is a command that you have to use as elevated user. NMAP is the name of the command, so that's all we're going to do. Then -s capital P is going to do a ping sweep. And then you got to tell it what network to do it on. So we're going to do the 10.211.55 network, so .0/24. That's the network for the VMs, okay? That's what VirtualBox and or Parallels in this case, or VMware would have set up. So you hit enter, type in your password, and it's going to start. It won't take long to run. See, it's already done. And it found Parallels itself, okay, my virtualization software. It found that because that acts as a router and a DNS server, right? Then it found the actual laptop, the host, and then it found the Windows machine, the Ubuntu machine, and the Kali machine. And all it's doing here is just saying host is up, and tells you what the latency is to it. Okay, so it basically just did a ping sweep. Okay, so now if we had this on the school's network, let's say there's 25 machines in there, it's gonna scan that whole 254 block network, and it's gonna find those 20 machines and say they're up or down. Okay. Now you can do a lot more with NMAP. We can do just a regular connect scan, okay? And what this is going to do is it's going to be very loud, very noisy, and people will probably see it, okay? But what it's going to do is it's going to do a full TCP connection to every machine and see if it can reach it. So it's going to send a SYN, then the other machine is going to send a SYN-ACK, and then it's going to send back an ACK, okay? So you get 3 packets at a minimum are going to go out. And all we're going to do with that, to do that, it's just, you're going to change the, instead of doing all the ports though, remember there's 65,535 ports on TCP, okay? We're not going to do all of those, because to do that for every machine on the network, it might take a minute, okay? So what we're going to do is we're going to specify some ports to use. So we're going to come back and say s capital T for TCP connect scan. Then we're going to put in the -P for ports. So -P, and then we're going to add some ports. Okay, we're going to do port 53, which is DNS. Okay, put a comma in. Port 80, which is a web port for unencrypted mail, for your standard HTTP. And then we're going to put in 443, which is your HTTPS, your encrypted traffic, right? And we're going to hit go, and this will take just a minute. And now you can see each machine, you can see what it's done here. Let's go ahead and make this larger. All right, where did we start? There we go. All right, so you see the first one, it scanned, which is Parallels, the virtualization. Okay, it scanned that, and it saw that port 53 was open, because that's what's providing DNS to all of your virtual machines. So that would naturally be open. Port 80 is closed and port 443 is closed. But notice this, it gives you the MAC address of the machine. Okay, that's the media access control. That's the hardware address that should never be it should always be the same. It should never change, and they're all unique. So you got that information. That's pretty good. Then if you look at number 2.2, which is the laptop, and everything's closed on it, but you got a MAC address. And if you on a MAC address, I don't know if you guys know this, I don't think we've covered it, but you see the MAC address, it's got 6 sets of 2 digits. Okay, those are in hexadecimal, okay, base 16 encoding. And if you look at the first 3, that's the manufacturer. So the first 3, everything from Dell is going to have a different first 3 than everything from, say, Apple, right? So if you've got 100 different machines and they're from like 20 different manufacturers, you're going to have 20 different sets of the first 3 digits. The second 3 digits are the unique identifier for that machine, for that hardware address. So as you look through this, you might start seeing some similarities. Look at the first one, which is virtual machine, the actual parallels. 00:1C:42. If you look down at the VMs as we get down there, they're going to start with the same first 3. And yours will probably be a little bit different because you're running VirtualBox. If you actually look at it, you'll probably see that it's they have a different first 3 for VirtualBox. All right, but if we look through here, none of the virtual machines have anything open. Okay, nor does the Mac. So the only thing we saw was the DNS for the actual virtualization software. All right, so what if we don't want to be noisy like that? Okay, what if we kind of want to be stealthy? There's a switch for that, right? So if we look at this, and we're going to do the same thing, we're going to hit the same ports, but instead of being really, really loud and saying, hey, here's my SYN, and have the machine send back a SYN ACK and then us send a ACK back over there, we're going to send a SYN, and when that machine sends back an ACK, we're going to say, later, and just walk away. Ignore it, right? So all you're going to see is that one packet, and you're not going to see a complete connection. So the chances of somebody on that network actually seeing what's going on is much less, okay? So all we have to do is change one letter here. We're still going to do the same ports, still going to be a SYN, a sweep. So we're going to do what is it? I believe it's just a capital S here. Yep. And so now it's going to do this. It's going to do the exact same scan, and you'll see it comes back with the same results, okay? Reason being is if the port's not open, it's not really going to connect to it at all anyway, just like it did before, so you'll get the same response. If the port's open, it'll say, yeah, I'll talk to you on this port, but we're not going to respond. So you still get the same results, right? But you did it in half as many packets, so hopefully nobody will see it. All right, so what if we want to dig a little deeper? We can do, we'll go to the same one here. We're going to get rid of the port statement and the scanning type. And for the scanning type, we're going to put capital O. Okay? What this is going to do is it's going to try to identify the operating system that is answering. Okay? And it can do that in a lot of ways. Like if you go to a Windows machine, you're going to see almost always, you're going to see port 135 open, 139, possibly 137, and port 445, because that's how Windows communicates with its domains and work groups and stuff. So it's pretty easy to identify. A Linux machine, if it hasn't been hardened, is probably going to have SSH on it, and you'll see port 22 open. Okay, the way that the packets respond. Okay, like if how it assigns a sequence number. Okay, that is a way to tell if it's a Windows machine or a Mac or a Linux machine. Okay, because the way it assigns that sequence number, Linux and Macs, anything Unix based, is going to be very, very randomized. Okay, so it literally just randomizes that sequence number. Windows, on the other hand, and this is why Windows gets breached all the time, is because it's very predictive. It's going to use a sequential sequence number. So it's kind of, that's one way you can tell. And there's other ways too. But we'll go ahead and start this. This one takes, a little bit longer, but it's going to look at every packet and every interaction and try to determine what the operating system is. And sometimes, and it's a guess, but most of the time it's pretty accurate. So, we got some information back. All right, so the first one here is the virtualization server. Okay, that's the .1. And as you can see, it sees that port 53 is open. You can kind of see it there. It's really hard to see in this because there's so much stuff up here, but let's see if I can highlight it. Okay, you can see right there, it's seeing that the port is open for domain. Then it's telling you the MAC address, and it's telling you its parallels. That's the next one down, right here. It's telling you a device type. It's acting as a kind of a firewall. And here's where it starts guessing some stuff. It's guessing that it's Fortinet embedded firewall software, which it could be. We won't know unless we actually were able to get the source code of parallels and reverse engineer it and see if it's literally using Fortinet's FortiGuard. Okay. Then we get down here, and it also tells you the, see it has down here no exact OS match, but it's guessing, and it's pretty close so far. And it's telling you that the distance is 1 hop away. Okay, so remember when we did a trace route, and like it went from one spot, then it went to the next spot, then the next spot, and those are hops. Okay, so it would tell you like from between here and my server in Germany, there's like 14 hops. Okay, and each hop is a router or a device that's going through that is routing anyway. All right, so here we look at the second one, which is the actual MAC. Okay, and you can see the ports here. Now that we scanned more ports other than 53, 80, and 443, you can see it found some other open ports, 2968, 5000, and 7000. And you can see the bottom one there, the 7000, is an AFS3 file server. That's how Macs do their file sharing. Okay. And if we scan down, you can see the MAC address, and it says unknown. And then down here for OS details, it says it's Mac OS. It's, it doesn't know much about the newer version because this is 26 whatever, I think it is, the latest version of Mac OS, so whatever that is. And it's telling you again 1 hop in distance. And then we've gotten down here, the next one, it says it's Windows 11, okay? And that right there is done from the reverse DNS lookup, okay? So it looked up the IP address, and that's what the Parallels DNS server returned. So you could actually look at that and say, okay, well, yeah, this is Windows 11, but if somebody named it, Bob's your uncle, then it's not going to know what it is from the name. But as you scroll down through it, you can see right here, here's the ports that are open. And it's telling you that it's port 135, 139, and 445, okay, which is going to automatically say it's probably a Windows box. Then if you scroll down a little bit, it's got a TCP/IP fingerprint. Okay, so this is just more information that it's getting, but it can, from all that right there, you can pretty much guess that this is a Windows machine, right? So then if we scroll down, now we get to the Ubuntu machine. And it really didn't get a whole lot on that. Same with the Kali machine. It didn't come up with a whole lot at all. It just tells you that it scanned all 1,000 ports and nothing's open. Everything's closed, okay, because they're both hardened. Kali by default, Ubuntu because I just didn't put a lot in it. All right, so, okay, there's another way that we can do this. And it does the same thing, but we're going to do it with the -A. And what this is going to do is it's going to add a little more information to it. It's going to go ahead and do a trace route to the machine, it's going to do, where is it? It's going to also scan, not just the OS, but it's going to do a trace route, and it's going to do a protocol scan and see, like, if there's a port open, what the headers are or the banners on that port to see if it can guess it.
So A means more information?
Yeah. And you can get help on this. If you want to see all the commands for this, just type in man space NMAP, and it will give you lots of stuff. There's a ton of options and things you can do. So while this one's working, there's another one that we can do. Once we do this one, it comes up and says, here's all the banners. So we can see that, what version of DNS is it running? What version of a web server is it running? And all that stuff, right? Well, then we can run scripts with this. Okay, so we could do like -- scripts instead of the -A, and then put in the script we want to run. Okay, and NMAP, they have a huge number of scripts that are available, and they have them in categories. So we could do the vuln category, VULN, and it will scan those the IPs we put in and look for vulnerabilities that every one of those apply to. So you can immediately just say, all right, we have an Apache web server, and it's vulnerable to these 10 things. So then, as an attacker, you could say, okay, well, I got a starting point. I got an IP address, it's vulnerable to these 10 vulnerabilities. I just go find some proof of concept code to run against it. And then you just run that against it, typically a Python script. All right, this thing's still running. It'll take it a minute because, like I say, it's trying to guess everything. It's doing the 1,000 most common ports. Okay, so it's doing 1,000 ports against every one of those machines. Now it's trying to guess the OS and trying to get the banners off every one of the ports and doing a trace route to it. And of course, trace route takes a minute because it has to send the ping back and forth, everything. So.
Okay, so the S is script, right?
No, it would be, I think it's -SCR. Do a man, MAN.
I'm just typing on my
Oh, you're typing it,
I
yeah.
can't even get to anything.
Okay, so you can do it on your Mac. You can just open up a terminal window in Mac. Well, it's not going to be installed on your Mac. Never mind. Never mind. Yeah, that's not a default Mac program.
But S is, you said script and sweep. Is it sweep?
Yeah, the little S, think of that as scan. Okay, scan, sweep. Then you would put something, capital letter behind it, like a T would be for a full TCP connect. Capital S would be for a stealth scan. And there's a bunch of other ones in there. I'll show you as soon as this finishes running. I'll bring it up and we can talk through some of them. But to do a script, you would do -- script and then space VULN, and that would do all the vulnerabilities against those IPs to find out if they're susceptible to any of them. There we go. All right, so now we can see where things have changed. All right, so, here is the Macintosh, or the Apple. And you can see port 5000 right here. And here's what it got out of it. Okay, let's go down. Yep, right there. So it got all that information out of it. Okay, it's telling you it's servers AirTunes version 920.10.1. So now you would run and you go to like the vulndb and type that in and say, is there any known vulnerabilities for the AirTunes version 920.10.1? And if it said yes, and it would say here it is, then you'd look and see how many scripts are in there that would allow you to try to exploit it. Okay.
Who made that? The vulnerability command. Why did they make that command?
Well, this is like say if we're doing this for the company you work for, right? Your job might be to find out which vulnerable software applications you have deployed, especially if it's internet facing. Because if it's internet facing, you got a bunch of little miscreants all over the world that are going to try to crack it. So that's why you do it for yourself. So the guys that wrote the software, they're security guys, not hackers and crackers, right? Although all the hackers use it, that's why we have it. So we can see what's vulnerable. So we can patch the holes before somebody breaks in. And believe me, they're trying every day. If you watch your home internet connection, okay, if you may have to, depending on how you're set up and what devices you have, you could get your logs from your router, and I'll guarantee you get tens, maybe hundreds of thousands of attacks a day at your house, and your router's keeping them out. Believe me, Comporium's not keeping them out. So, all righty. So, and then of course, huh?
What's slurp?
Well, you may have to try it. So there's a lot of commands, and you see it found a lot of information off each of the hosts except for the Ubuntu and the Kali because they're hardened. Okay, there's nothing external on those two devices that anybody can mess with. So here we'll do the man command, and all you do, man is for manual, so. Every software program on Unix will have a man page for it. So if we hit that, here's all your commands for NMAP. All right, so if we start scrolling down, it gives you an example of how to run it. And that -T4 is basically telling you the velocity of it, how fast you want it to run. So you can speed it up, slow it down. So, like say our network, if somebody comes in too fast with too many questions, too many, say to our website, our web server, if they come in and say, hey, I want to see your web page, right? They do a GET request for that web page. All right, well, if we get one, we give them the web page. If they send 4,000 of those in a second, after about the fourth one, we're like, yeah, goodbye. And we turn them off so they can't access it. And that's to keep people from, doing a denial of service and bringing your website down. All right, so let's go through some of the options. All right, right off the bat here, we can do -lowercase I, uppercase L, and we can put in an input list. So like if we had 500 hosts out of 10 million hosts, we just put in 500 and on that list, and it would just read that list and just do those 500, right? Let's see, what else we got? -S, capital L, list scan, simply list targets to scan. Okay, so if you throw a network in there, a network with a CIDR address, it'll tell you how many hosts are in there that you're going to be scanning. SN, lowercase s, lowercase n, a ping scan. Okay, capital P, lowercase n, treat all hosts as online. Okay, so it's not going to do host discovery, right? So with host discovery, it's going to send out ICMP request, are you up? And if it comes back and says, yes, I'm up, then it's going to say, okay, make a note, that's the guy I'm going to scan. Then it goes through and does that for 10 more, and they all come back with no response. He skips those, right? So it saves it time. So if we do a -PN, treat all hosts as online, it's going to basically, if you give it a block of 254 IPs, it's going to scan every one of those regardless of whether it's up or not. So it's wasting time, right? So if you know you only got 3 machines on this network, why would you scan the other 251 hosts with 1,000 hosts or 65,000 ports or whatever? Just doesn't make sense. Let's see here. So you can see there's a lot of options. Scan techniques. This is where we were mostly working, was in this area right here. We were doing the SS, the ST. Then here's you can do a SO, which is an IP protocol scan. Port selection and order. Okay, here, this is how we determine what ports to scan. And as you can see, it's pretty flexible. We do a -P, specifies the port, and then you put the ports behind it. So you could put in 1-65535, and it's going to scan all 65,535 ports on each IP, okay? And that's just TCP. If you want to do UDP, you have to put a U in front of it, like a capital U colon, and then the ports you want to scan. You can see that it's like right here. Okay, so if you do P1 through 65.535, it's going to scan all the TCP ports. If you put that capital U colon and then some ports in there, it's going to scan all of those on UDP. And the way you can do ranges is pretty cool. You can do like 53, 80, 443, right? Or you can do 1, 1024 for 1024, okay, and that'll scan basically the first 1024 ports, then then say you want to do everything between 65,000 and 65,535, and it would do those. So, I mean, you can get very specific about what ports you're scanning. Yeah, let's see here. See, right here is script. It's S capital C is equivalent to -- script. So, and here I'll show you, we'll go see if we can get the list real quick of ports. Let's see. NMAP scripting engine. I think this has a list of them. Let's see if it'll come up. Yeah, school's Wi-Fi is slow. All right, so we won't mess with that. We'll give it a few minutes, see if it comes up. Or not. Not that one. There we go. All right, you've also got some other options down here for like timing. You know, you could actually put this into a delay mode, okay, and have it like, you know, scan one port on one host, wait somewhere between 2 and 20 seconds, then scan another port on another host, keep track of them all, and then, you know, put it all back together when it's done. And, you know, that dramatically increases the time of how long it's going to take, but you can do it. And you can see like some firewall IDS evasion and spoofing. Like a real good one is the decoy, okay? And I'll demo that one real quick. But with decoys, you can actually, you know, if you're the one doing all the scanning, right? And you're sending out from you to every host on the network a bunch of scans, okay? You're gonna stick out like a sore thumb. But what if you sent a packet and then you sent 25 packets that are spoofed to an IP address that's not even online, and that traffic's just on the network? At that point, you can blend in. So we'll do that real quick. And then it gives you a few examples down here. And the rest is just you know, kind of explanations of some of the commands in a little more detail. So I'm going to go ahead and hit Q and get out of that. And let's put a decoy in. And let's see. All right. We're going to do this command right here with the 3 ports on the network, but we're going to do a -D for decoy. Then we're going to put in, let's see, 10.211.55.57, because 57, you know, on this network, on the laptop, there's only 3 hosts plus the laptop, right? So we'll use something way out of the range, okay? So this is 50 away. And so now if we do the scan, it's doing the scan from 2 different machines, okay? Now you don't see it here, but we can show you that. We're going to go to Wireshark. What Wireshark does, and you guys will use this a lot if you're going to pursue this as a career, but it lets you see what's happening on the wire, okay, or the radio transmissions. Okay, it breaks it out, and it's a protocol decoder. So like if you intercept traffic, if it's clear text, you're going to see clear text. You're going to see exactly what the user is going to get. If it's not clear text and it's encrypted, depending on what it is, you may be able to decrypt it. Like there's some tools that we might use called like AirCrack, where we can actually just sit here and turn on a sniffer, aka Wireshark, and intercept the Wi-Fi signals floating around in the air, okay? Sort out the one we want to look at, capture a big chunk of it, and then play it back through AirCrack or something similar, and actually it can, in a lot of cases, depending on the encryption, it can break the encryption, and then you can get like the Wi-Fi passwords out of it, or you can watch somebody's traffic, you know, see what they're doing. All right, so let's try this. Let's start a capture. Capture, options. And we don't have a broadcast domain right now, so let me just see if we can get it to say something out there. Well, there we go. All right, so ETH0 and any. So we're going to look at ETH0. And I've got a filter in here. You see that green bar right there? It says not broadcast and not multicast. Okay, so we're going to take those packets out. We're not going to look at those. All right, so if we hit capture now, and you hit the shark fin over there, that's how you start capturing, you know, because it's Wireshark, you know. Developers have senses of humor. Okay, so now it's capturing. So anything that's destined for that network or for the network on the laptop here, and you can see we're starting to get some packets in. Okay, and this is just routine, normal traffic on the network. So let's drop down and go back to our scan over here, and let's scan it this time without the decoy. All right, and that probably just went absolutely bonkers with tons of stuff. All right, so let me stop the scan now. All right, so if we look up here, Kali is .4, okay? So these things are color-coded to kind of help you see what's going on, right? So the green ones here, these are a SYN connect right here. You can see it's trying to do a SYN, okay? Now this is going out to .2, okay? So Kali, or NMAP on Kali is now going, hey, what do you got on port 80? That's all it did. It just said, hey, I want to talk on port 80. Nothing happened, okay? Because there's no web server on port 80, right? So how's it going to answer? It doesn't. So it tried it 4 times, and then it said, meh, it's closed. Next, okay? Now right here, it tried it, or here's the response from it, okay? Because it's closed, it come back immediately with a reset. Okay, that's why it's a red packet, okay? Now, you can actually see what's going on here. So if we go, let's open one of these up, all right? And you can see the top is what's happening on the wire. So here's the frame, so we collapse that. And this is telling you the basic synopsis of a TCP packet. Everything's encapsulated, right? So you got, you know, a frame holds in the the lower parts of it, the protocols, and then finally it gets to like the presentation layer, which is like HTTP and showing you your web page. Okay, so you can scroll through this. The second part of the encapsulation is the Ethernet frame, and you can see where it was going. Here's the destination, but notice there's no IP address in there. It's just a MAC address. Okay, because everything communicates with a MAC address. Once it knows the MAC address, it can talk hardware interface to hardware interface. But you know, you do have routing protocols on top of that. So you have the internet protocols. You have that is encapsulated in there, and this will actually tell you the IP address of the source and the destination and what ports it's trying to talk on. Okay, and then we scroll down, and then you got the actual TCP control, okay, where it tells you the ports that it's talking to and what's going on, what flags are set, and you'll do a lot with flags here because that, you know, this one right here, to, if I can get it to highlight, there we go. But you can see it says send, okay, and that's the initial packet. Hello, I'd like to talk, you know. So that was with just NMAP saying, I'm going to scan and do my job, and we don't care about if anybody sees us, right? And you see in here, you've got just everything talking to and from .4, okay? Everything talking to and from Cali. Now let's go ahead and clear this. All right, let's go do another capture. And we got our broadcast in. Okay, we're good. So we just got to hit go. Say continue without saving. Okay, so now we're ready to do another scan, but this time we're going to put the decoy in. All right, so this one is also going to be transmitting all the information as though it was .57. Okay, so it's done. So let's jump back over to Wireshark and stop it. And look at this. You can see traffic interspersed in here from 57. So you basically, now you can put multiples in there. So you just put 57, comma, whatever the next one is, comma, whatever. You can put a whole army of them in there. And you don't have to do it from this network. They could be from Google's network or Microsoft's network or whatever you want to, because you're spoofing it, okay? And that's how that works. So we can look at one of these packets. Let's just look at one of these. Okay, here's one where 57 sent a send packet to port 53 on .1. Okay, and you'll see it send out. You'll see the reset come back, but the reset doesn't go anywhere because guess what? .57 does not exist on the network. You know, there's no host that will answer it. So it's just noise. That's all it is. So it makes it easier to hide. Somebody, if you've got like one person that's doing a scan and he's also putting decoys in for like 50 other machines, it's going to take you a little while to sort out which one is the legit scanner and which one is noise. So that's why we do that. All right, so what else is on the notes? All right, I think we covered all the NMAP stuff we wanted to cover, except for turning it loose on the network. Look, we got a few minutes. Let's see what we can find. Huh?
Oh, yeah, that's. See, I don't know. Is that really Cali? It's just like the terminal. It's not trying to.
Did you just get the terminal window again? It's basically, you have no graphical user interface. You have just a terminal, which is the most powerful thing. But,
and that's working, but nothing, like I can't do anything with it. Like if there's like error codes. Like,
did you try doing like NMAP on it?
I tried like the first part and it's like not found.
So NMAP's not found on it? That's on Ubuntu, right? Or is that Kali?
This is on Kali.
Okay, it should have NMAP in there. Just type in nmap-h.
Oh, I did like the first part, and it's just loading.
Oh yes, I think you're struggling to actually to run it. So, well, the good thing about this is that you can see everything here and have an idea of what it does. So, and you can do it from your Mac. I mean, you can install NMAP on your Mac in the terminal. It's just going to be a little bit different. It's not going to be, apt install NMAP. You're going to have to go get the Mac redistributable or compile it, which adds a lot more, keystrokes. But
yeah, and you know what? Sometimes I can't even put my password in, so I don't know how to do that.
All right, so let's try just a simple scan real quick of the network here and see what we get, because this might take a minute. 2.0/24. All right, we're not going to put a decoy in here. Tell you what, let's don't even put ports in. Let's just see what's up. And we'll just do an S. All right, let's see what happens. Now you really should have permission to scan like this, like either, like at your house is fine because you own it. Your mom and dad probably will say, oh yeah, sure, for educational purposes, go for it, right? So, but don't do this to, a company that you don't own or that the company has not asked you to do it. I mean, technically, it's not really, scanning a network is not really illegal, but there's a gray area there. It could cost you issues. All right, so look, we got a few things. We found, we scanned 256 IP addresses, and there's 256 of them that are up. But that might be church assets. It might be, the thermostats. If you look at that thermostat, that's a Nest thermostat. It's got an internet connection. All that stuff's up. So you could go a little bit further, and we could say, what is what? So let's do the O one's going to take way too long, but let's try it. See what happens. All right, so this will scan those same 256 addresses. And remember, there's only 254 addressable IPs in there. The first one's, the network, and the last one's the broadcast. So, and we're not, we weren't even capturing those in the Wireshark capture that we did because it's just too much traffic because all these machines are talking to each other all the time. Okay, they're always broadcasting. Who has this IP address? Do you know where this guy's at? Stuff like that. Or if somebody broadcasts, technically a machine could broadcast and say, hey, I am doing this right now. I have this streaming media available.
Port really open?
Whoop. So there you go. You've got, it's finding some stuff. But this time it's looking at that top 1,000 ports, right? And it's looking at those 1,000 ports and saying, what's open on it? Can I determine if, what OS is running? Ooh, like right here it found what it thinks is a HP wireless print server. So they probably got a Wi-Fi printer in here somewhere. So network cameras are the easiest to do because they're typically, they don't put security on them. Even our company, we were scanning for network cameras one time, just for, in general, devices on the network that we have designated for like, thermostats and cameras and, miscellaneous equipment like that. And we found like a bunch of them and they didn't even have a password on them. So we were like, oh, look, this one's in Nashville. This one, oh,
Wait,
look.
cameras or,
Cameras.
You would think cameras would have passwords on them.
You would think, but they never set it up initially. And we went and told the guys that maintain them, and they're like, oh, yeah, we should change that. And they password protected them then. But that's why we do this. As a security professional, you go after to find where your vulnerabilities are at, right? And if you find a vulnerability, you get with the people and say, we got to fix this because this is a problem and it could lead to a breach or a loss of information or something.
So what happened if somebody scammed, like, or was posing as a person who, like, fixes this stuff, but ended up getting access to them, like, found out, like, see, I feel like cybersecurity can be such an evil job. Pose as a good guy and then really do that. What happened to that guy you guys found that was, like, in
Yeah. I mean, he was a bad guy and posing as a good guy. And it took us to find him. And then, of course, he was terminated just a few days after we hired him. But yeah, that's why we do it. I mean, it's a tough job. And we get paid well, but we don't get paid nowhere near what the bad guys get paid. I mean, like, we had an incident last week where a very large payment was made to somebody, and he probably had to do 30 minutes worth of work, and he brought home $85,000. So, and we were probably just one of the many he did that day.
Really?
Yes. So, all right, 9:25. I guess that's it. Hopefully, this recording actually worked. Yep. Oh, it worked good.
I don't think it'll take.
Oh, it only worked for 5 minutes.
We need to see
Bummer.
what he's running.
All right. On the website, or on YouTube, I put there's a demo on running NMAP. So